Okay, good morning, everyone. Okay, today, as you guys know, we are doing a review for our exam. So the exam is this Wednesday, as you guys should know. I have the review on Brightspace, and I would like to start the exam at, let's see, at 10:45. So the exam will be open at 10:45. So to take care of the technology stuff, and it will close at 12:50. And I want all the camera on during the exam. Okay, so today what we're going to do is actually a review. I did give you the review. I will go over some of the problems, and if you guys have any questions or whatsoever, you please get going. So first I start. Do you have any questions from the review before I take over? Anybody has any question, please put them on chat or communicate them. Anyone? Okay. So I will get going with the review. I will not review everything, definitely, but I will review first the part that we've talked about last Wednesday, just to make sure that this is very clear. And then we have extra time, we will do other problems. So I'm going to first start focusing on the stuff we did last Wednesday, and then with the leftover time, we will do the rest. So I hope you guys have the review with you. Okay, 7, Rebecca, 7 where? The review or the book? The review. Very good. So I will start with number 7, and I will do, my plan is to do 7, 8, 9, 10, 11, because that's from last Wednesday, to make sure you guys know it, and then we proceed. So I will do number 7. Okay, and the question is, solve the following equation. And I'm asking only for one solution. 9 minus 1 equal 3 tangent 4 theta. Okay, so I need to find an angle theta that when I put it in this equation will be satisfied. All right, so ideas, how would we approach this type of problems? What would you do? An input. Okay. The way to do those type of problems, first we actually need to isolate the tangent, because that's the only way I know how to deal with the problem. So we isolate the tangent term. So what do I mean by that? Exactly, we're going to move everything to one side. So this is 3 tangent. I'm going to subtract 3 tangent from both sides. So subtract 3 tangent 4 theta from both sides. Okay, so this will give me, I take away 3 tangent from here, 3 tangent from here. This would give me 6 tangent 4 theta minus 1 equal to 0. Now we need to isolate this term, so we can use the arctangent. So I add 1 both sides. 1. Again, I need to isolate the tangent. I divide by 1/6. Okay. Now I am ready to use arctangent. So first we have to isolate this term. Once we isolate it, then I use the arctangent. But this tells me that this is the tangent of 4 theta. This tells me that 4 theta, what's inside the tangent, the 4 theta, is arctangent 1/6. And I want the angle in radian, and on the test, I try to remember to tell you which unit I want. So let us see, I want the angle in radian number, but what I want you to be careful here is that it's the 4 theta, which is the arctangent 1/6. So 4 theta equal, now I have to pick up my calculator and I have to evaluate the arctangent. So first I need to check the mode I am in. Okay, I'm in radian mode, so I'm good to go. So I need the tangent inverse of 1/6, which will give me 0.16514. So point up to 1651. And then I'll get to my theta, which is 0.1651 divided by 4. And this will give me, we divide this by 4, and this will give me 0.041. And if I round it up a little bit at this stage, 1/3. All right, so that's really the idea. Whenever you have any equation, it's not very complicated, but it involves tangent or cosine. You first need to isolate the tangent term. Once you isolate the tangent term, you can use the arctangent, but we have to be careful with that's the 4 theta, which is the arctangent, not theta. So once you find 4 theta, and then you divide by 4 and you get your theta. All right? Questions about that? So if you guys have questions, you put them on chat. If you don't, I will just keep moving myself. But please, I really appreciate if you guys put your question on chat. It's nice to know what you guys are having trouble with. Now, along the same line, so if we have number 8, before I move on to number 9. Okay, so number 8 is very much the same, but instead of tangent, I can give you sine, I can give you cosine, I can give you anything I want. So this will give you, I use t for the angle, plus 2 equal the cosine of 5t. And the question is solve for t. So I will give you a minute to give me 2 minutes to give me the answer, and please do it quick because I want to go through the other problems. We're going through problem number 8 on the review. Thanks. Number 8, the one that followed. I think so. Yeah, that's number 8 on the review. The review problems and the one I assigned from the homework are very much the same. So I picked the review problems. Okay, anybody else? I need more than one answer to make sure you guys are getting it correct. Anybody else got the problem? Okay. Anybody beside the 2 students? All right, so they seem to agree on the same number. So again, it's the same principle. We need to isolate the cosine. So I take away cosine 5t from both sides. Take away, so subtract cosine 5t. This would give me 3 cosine 5t equal to minus 2. I have to isolate it to be able to solve. Now I have to divide by 3. It's minus 2/3. Now I am ready to take the inverse cosine. So that's my 5t here. So it's my 5t, which is the cosine inverse of minus 2/3. And if we evaluate this, I will have 5t equal 2.3005. So my t is this term divided by 5. And what your classmates are getting is absolutely correct. So it's 0.4601. Okay, and this will take care of those type of problems. These questions as I move on. Okay, now we're going to move to number 9 and 10 and 11. We'll definitely have problems along those lines on the exam, and we have to make sure you guys can do them well. Okay. Number 9, from the review as well. Everything I'm doing is from the review. Okay, we have the following function. F of t equal, the cosine of 40. Okay, f of t is cosine 40. So my first question is, so these are the sinusoidal function that basically look like the cosine, but what's going to change is the period. So my first question is find the period and sketch the graph over one period. So let us remember the period. So here the b is the 4, and the period is always 2 pi over the b. It means 2 pi over 4, which is pi over 2. It means this is a function that looks like the cosine, but it repeats itself every pi over 2. So we're going to sketch it. I did not give you the graph here because we should be able to sketch it. So let us remember how we sketch. This is t, and this is the function. The period is pi over 2. So I'm going to put here pi over 2. It means we're going to have a full cycle between 0 and pi over 2. So that's a function that looks exactly like cosine, but this is the period. So first, I divide this into 4 equal pieces. I try to be careful, 4 equal. And then let us see how the graph of cosine looks like. It starts at the highest value. The amplitude is 1, so it's going to be 1. That's minus 1. And it goes like this. It starts, it's going to be 0 here. It goes down. And then, this is 1 here. So it's 1 here, and I will tilt it more carefully. It's going to be like this. Okay. And what characterizes the cosine is that the graph has a total symmetry. It means this piece is the mirror image of that. Okay, so that's really the period pi over 2. So this point should be, for example, pi over 4. And it's nice to know what's really happening here. And this is something we did at the beginning of the semester. Okay, now question is, you use arc cosine to solve f of t equal minus 0.9. So now I'm asking you for which t the function takes the value minus 0.9. So graphically, minus 0.9 is right here. That's minus 1.9. What I'm asking you is, I want the value where the function takes the value minus 0.9. So how do we do that? So we're going to set cosine 40 equal minus 0.9 and solve 40. Right. This is not hard here because the cosine is very well isolated. So it means that to solve this is going to give me 40 is the cosine inverse of minus 0.9. It means that my t is cosine inverse divided by 4. So that's so far the t. And everything is in region here. So we're going to get the cosine inverse of minus 0.9 divided by 4 is giving me 0.673. I will accept that. Okay? And that's in region. That's the value in radians. So it's less than, of course, less than 1 radian. All right, so that's f of t. Now my question is, use arc cosine to find one solution of this function, and then use the symmetry to find another solution. So what is really going on? When I solved arc cosine, I got one solution. From the graph over one period, we realize there are two values of t that satisfy f of t equal minus 0.9. The 0.7 is this one. So the function arc sine is giving me one value. That's the 0.73. That's one value. Okay. And now I want you to use the symmetry of the graph to find the other one. It means I want you to use the symmetry to find this one. The main hint I can give you is that the graph of cosine, this line can work as an axis of symmetry. It means if you take this piece of the graph, it's the mirror image of that piece. So how can we use the symmetry to figure out the second value? Can anybody a little bit pitch in? Pi over 2. Anybody else? Anybody else? So imagine if you take those two pieces and you kind of put them on the top of each other, they should totally agree. So what this is value you think? Just using the symmetry now. I don't want anything else. Anybody agree with your classmate? Let's see how the symmetry works. The symmetry tells me that from here to here and this, those are equal. So the symmetry, that's how I'm using the symmetry. This piece from here to here and this piece from here to here, those are exactly the same. So how can this help us? It means if I have 0.673, it means this piece here is 0.673, this one. So what's left from here to here, this is going to be the pi over 2 minus 0.673. So that's how we are finding actually those values. That's how we're using the symmetry of the unit circle. So if I call this T1, if you want, just to make it, then the second value T2, so I call this is T1. I call this T2. So T2 is going to be pi over 2. I will take away from it 0.673. So absolute using, and the students are getting 0.898, and I will trust their answer. So that's what I want to have the idea of a symmetry. So the graph of cosine has a total symmetry with respect to this line. Means those are mirror image of each other. So graphically, if this is points, those two are equal. So I want from here to here. So I take, okay, it's pi over 2, take away this little piece. That's what I'm left with. Okay, that's how we're going to do those type of problems. Questions before I proceed? All right, so now I'm going to take the other one. As I said, I would like to review those from the review because they are based on last lecture, and you will definitely have those type. I mean, everything on this review, you will have it. All right, problem number 2 was the following. Number 10. I have a function f of t. It's 5 minus 4 cosine pi over 2 over t. That's my function. And I gave you the graph this time just to make the problem much easier for us. My question first is find the amplitude, the midline, and the period. Okay, so I'll go back to the graph in a second, but now first I have to answer the question. So here I have my f of t equal 5 minus 4 cosine pi over 2 times t. Okay, let us see what's the amplitude and the midline. The midline, so basically that's the way we read it. That's the cosine function stretched by a factor of 4. So we stretch it a little bit, we flip it, and then we add 5 at the end. So the midline is the line y equal to 5. The amplitude is equal to 4. The period, even though my graph shows the period, I'm aware of that, but we have to figure it out. Now here in this problem, the B is the pi over 2. So the period is 2 pi over B. Okay. And now we use a property of fraction. So it's 2 pi times 2 over pi, the pi which is equal to 4. Means the graph repeat itself every 4 units. So it's the graph of cosine repeating itself. And that's exactly what we're seeing right here. So that's the graph. We're starting from here. The graph go up, down after 4 units. That's the period. It start repeating. 4, go up, down. That's 8. And it start repeating. So the graph really repeat itself. That's really my period. So from here to here, if this is 4, this is my first cycle. That's 4 units. Up to here, another 4. Okay, so that's really the picture. Question number 2 is evaluate f of 2. That's a simple question, so but we will do it. So this is my A. Evaluate f of 2, it means plug in 2 into the formula. It means what's the output at 2? So I just plug in 2 in here, and I get 5 minus 4 cosine pi over 2 times 2. So I'm plugging 2 here. So I will get 5 minus 4 cosine, the 2 and the 2, basically, cosine pi. Now, cosine pi is an easy idea, so we should be able to find the cosine of pi. So cosine of pi is -1 because it's one of those particular angles. So this is -4 times -1, which is equal to 9. So f of 2 is equal to 9. And if we look at the graph I gave you, if this is 2 and go up to f of 2, this is actually 9. So whatever number I got agrees with my graph. Now, the question, use arc cosine to find one solution of f of t equals 7, and then use the symmetry in the graph to find all the other solutions. Okay, so we want to solve which t shall I plug in here so have an output of 7? Which t's I should plug here to get an output of 7? Whenever you're solving this type of graph, I usually advise you to sketch the midline. Midline usually help me, and if it helps me, it helps you. So we're going to sketch the midline first, so just to help us. So this is 5. Okay, this is my midline. That's midline. That's not really the answer to the problem. Okay, so that's the midline. That's 5. Just because it's really helpful sometimes. Now, my question is, we want to see when the function equal to 7. So I'll go to my graph and a little bit. This is 6, this is 7. So this is 7 right here. And I want to know all the value where the function is 7. So this is 7 right there. Okay, that's 7. Okay. And according to my graph, there are a lot of value. There is 1 value. There is another one, a third, and a fourth. So there are a lot of t's where f of t is equal to 7. We're going to use the arc cosine to find one of them, the first one, and then we use the symmetry and the periodicity to find the others. So first, I will find one of them. I'm going to find this one. And then we look at the graph, and I want you to find the other values. So step number 1, we're going to find one value. So we will find one value only first. Okay. So f of t equal to 7, it means 5. We're going to set cosine pi over 2 t equals 7 and solve for t. Now this we solve those problems exact same way we did number 7 and 8. We need to isolate the cosine. That's the only way out. Isolate the cosine. Okay. So to isolate it, I can take away 5 from both sides. Seven minus 5, which is going to give me a 2. This will give me the cosine equal minus a half. Okay, so this first step is to isolate a cosine. And now I have to use the inverse. So if the cosine pi over 2t is minus a half, it means pi over 2t is the cosine inverse of minus a half. Okay. Now, does any minus a half is a particular angle? It doesn't have to be. Does anybody remember which angle have for cosine minus a half? Anybody remember? If you don't, I mean, you can use your calculator to evaluate, but anybody remember which angle have for cosine minus a half? Remember the cosine is right here. Go back to my unit circle. And I'm looking for an angle whose cosine is minus a half. Anybody has any recollection of those? I can take the one whose cosine is a half. The one whose cosine is a half is the angle pi over 3, because pi over 3 gives me a half, square root of 3 over 2. So that's that. So my angle is going to be pi minus pi over 3, which is 2 pi over 3. Okay. And if you forgot, on the solution, I have the unit circle for you. You can go back to the unit circle. So if I want the cosine to be minus a half, which is right here, the angle is the 2 pi over 3. So I have on the solution this unit circle to help you out. So this is equal to 2 pi over 3. So now I have pi over 2t is 2 pi over 3. I want my t. I want the t. The t would be 2 pi over 3. I multiply to get rid of pi over 2 from this side. I multiply by 2 and I divide by pi. Am I correct? So it's going to give me t equal, pi and pi cancel each other out, t equal 4/3. I stop at this stage. Any questions? All right. So this is one solution. So I get T1 equal 4/3, which is one solution. So I get one of them. This one right here. So if I plot it up, down, this is one solution, which is the 4/3. Okay, now how can I get the other one? How can I get this one? I'll give you a minute to see if you guys can figure out this solution right here. And again, the period is 4. And this graph has it to do. This is 4 right here. And there is a symmetry in the graph. So what's going to be the second value? How do you think I'm going to get it? So this is 4/3. It means this is 4/3. How can I use the symmetry to get this value here? I'll let you think about it a little bit. Just use the idea of symmetry. Okay, so what do you think is going to be? Okay, exactly. This piece here That's the symmetry I'm talking about. This piece here is also 4/3. So this T2 is going to be 4 from here to here minus 4/3, which is going to give me 12 minus 4, which is going to give me 8/3. Okay, so that's how we are going to use the symmetry. So this is, the period is 4. We have total symmetry as a cosine. It means the line in between is, the graph is symmetric with respect to the line in between. If this is 4/3, from here to here 4/3, that's give me 4 minus 4/3. So we have T1, 4/3, T2 is 8/3. Now, what are the other values? What's this one? Remember, the graph starts repeating itself. It repeats itself every 4 units. So whatever the value is here, if you add 4, the graph repeats itself. So this is going to be exactly, it's going to be 4/3. So this is T3. It's going to be 4/3. You're adding 4 to it. That's what T3 is going to be, which is going to give me 4, which is going to give me 16/3. Now, what's this value here? It's the same as this one. It's this one, you add 4 to it because the graph repeats itself. So this is going to be the 8/3. You're adding the period, nothing changed. 3 times 4, 12, 12 plus 8, which will give me the 20/3. Okay, that's really how we're using the symmetry of the graph. So just look at the graph and start. So the first part was 4/3, and this is 4 minus it. And then after that, you add the period. Once you find two values between 0 and 4, to get the other one, you just have to add the 4. You add the period. That's really how you do it. You add the period, and then you will get the other values. And now we move on to number 11. Please ask questions. You guys are so quiet. Okay. Number 11. I gave you the function along the same line. I'm not changing the scenarios for those particular problems. So number 11, we have function f t equal 5 minus 4, but a sine pi over 3. T, that's not the cosine. The question is, again, find the amplitude, the midline, and the period. So the midline, I use a clean sheet. I'm going to keep this to graph things. So the midline. So my function is 5 minus 4 sine pi over 3 t. So my midline is y equal to 5. My amplitude is 4. And then the period. For the period, I need the b. B is pi over 3. It means the period is 2 pi over 3, which is 2 pi times 3 over pi, because I'm dividing by a fraction, so I multiply by the reciprocal, which is going to be equal pi, which is going to be equal to 6. So the period is equal to 6. So I have a function that look like minus sign, but it repeats itself, not every 2 pi, it repeats itself every 6 units. So that's really the period. It means the output of f repeat themselves every 6 units. Okay. Now question number 2 was evaluate f of 3. So again, it means you plug in 3 inside your formula and you evaluate. So f of 3 would be 5 minus 4 sine pi over 3 times 3. It means 5 minus 4 Sine 3 and 3, it's a pi. Again, by coincidence, it's an easy number. The sine of pi is equal to 0 because that's the y coordinate. It means this is equal to 5. So at 3, the function is equal to 5. Now, C. C is they want us to find one solution of f of t equal to 4, and then use the symmetry to find another one. So first, let us solve f of t equal to 4 and find only one solution for it. So f of t equal to 4. Okay, we're gonna solve this. It means 5 minus 4 sine pi over 3t equal to 4. Okay, I need to solve for that. So I will isolate my sine as usual. So to isolate the sine, I have to just subtract 5 from both sides. The 5. And this would give me minus 4 sine pi over 3t equal 4 minus 5, which is minus 1. It means the sine is 1 over 4. That's the sine of pi over 3. It's the sine of that. Now, 1 over 4, we don't recognize this. It's not like a half or minus a half that we know. This is, we have no idea, so we just choose. It means pi over 3 times t is the sine inverse of 1 over 4. Okay, so I'm finding one value. Then I'm going to use the graph to find the other one. So let's see what we get. Okay, so the sine inverse of 1/4, I'm getting 0.25, 0.25. I'm going to round to 3 decimal, 0.53. But this is pi over 3 times t is equal to that. Now I want t. So to get t, I say I can multiply both sides by 3 over pi. Okay, if I multiply both sides by 3 over pi, I can actually pull out my t and figure it out. So what I'm doing is I'm multiplying this by 3 over pi and multiply this by 3 over pi. The benefit is that this will help me to isolate the t here. And then here I can just multiply this. So 0.253 times 3 divided by pi. I'm getting 0.2416. I'm getting this value. Okay. So we solve this equation. It means we look for the value of t when I plug it here. It means if I take this t, plug it in here, I will get, honest to goodness, a 4. Now, this is not the only value of t which give us a 4. There are other values. And the other one, I want you to do it, to find it by looking at the graph and seeing the symmetry. So now I will go back to my graph. So that's the graph. And as I said before, I'm going to draw a little bit the midline so I can start understanding it better. So 6, this is 6, that's my period. The period is 6. And my midline is 5, so that's really my midline. So I'm going to draw midline because it orients us. Okay, that's the midline. Now, what do they want? They want when the function is equal to 4. This is the midline. 4 is right there. It means graphically, that's what I want. So this is my 4. So this is the 4. Okay, and what we want is this value. What's the t that gives me a 4? And as you realize by looking at the graph within a period, because I'm only asking you within a period, there is another value right here. Okay. Now, when we solved the 4 and used the arc sign, we got one of them. So when we use the arc sign, we got one value. So this is going to be 0.5 0.2416. So solving gave us this. Now I'm going to use the symmetry of the graph to be able to find this one here. Anybody can think about it. Remember, this is right here. This is F3 in here. And we use the symmetry. And now how to sign is symmetric. If you take this line here, this piece is a mirror image of that piece. This piece is a mirror image of that. That's how it's going to help us. So I will give you a minute because I want all of you to kind of, how can we use the symmetry to figure out this piece right there? And look at the graph. That's why I drew it, because I want you to see it from the graph, what's really going on. I want you to see the symmetry. It means this piece here are mirror image of each other. How can this help me to find the value here? Okay, 1 minute, I'll keep quiet. I want answers. I'm gonna pick one of you to see if you can figure it out. Yeah, I'm getting good ones. I have a question for after class. Sure, Jacob. Yes. Anybody else? Okay, I picked Caleb. Caleb, how did you figure out your answer? Caleb? Caleb, are you with me? I mean, you should. You wrote the answer. Okay. Jaden, how did you figure out the answer?
So I realized the 3 point and the point we're trying to find are the same distance as the 0 and 0.2416. So I did 3 minus 0.2416 to find the point.
Right. So the symmetry tells me this little distance, that's exactly how we're doing, and this are exactly the same. That's really how the symmetry is. So this is it means this is 0.24616. That's really what's happening. So my value T2 is going to be 3 minus 0.2416. That's exactly that's how we're seeing the symmetry in this problem. All right, so the second value, T2, so that's the first one. So T2 is going to be 3 minus that, which is, I don't know, we just compute this value. So 3 minus 0.2416, and this will give me 2.7584. Okay, and that would be the second value. So you have to graph, and you have to deal with symmetry to find the other value. It's not very hard, but it's not actually very hard. But you have to really be careful with the symmetry, what's really going on. So the graph of sine, it has two pieces. That's the graph of sine. And from here to here, we have symmetry with respect to this line. And from here to here, we have a symmetry with respect to this line. And that's really what's going on in those graphs. Questions? All right. So this is what was relevant to last lecture. Just for my own peace of mind, before I move on, I'm going to give you the following function. Suppose I take f of t equal sine. I mean, it's not on the review. I'm just making up my own problem. Sine of, let us say, 3t. No, I want something easy. 2t. Okay. And my question is find the period. Question number 1. Question number 2, we're going to graph. And question over 1 period. And then I want you to solve f of t equal, let us say, I don't have a lot of choices here. Let f of t equal 1/3. That's really my question. And 1, I want all solution within a period. a period. So just that's an extra problem just for us to do. All right, so we do part A together. Okay, what's the period? But what's the period? I have a question for, okay, the period is pi. Is he correct? My B is 2. My period is 2 pi over 2. My period is pi. So now graph. Graphing, this is the graph of a sine function. That's exactly a sine. I'm not shifting up, I'm not shifting down. That's the sine. And the period is pi. It means the graph finishes the cycle within pi. So this is a pi. And the way I like to graph this, I like to go, this guide us. So that's halfway and the fourth. The sine start from here. That's the positive sign. It goes, it's max at 1. And then this move in a pure symmetrical way with respect to the other piece. And then it goes down and total symmetry with the respect to the other piece. So that's really how the graph looks like. So this value here is not hard. If this is pi, this is going to be, of course, pi halfway through. And now, at this stage, I want you to solve f of t equal a third. And according to my graph, there are 2 values where the function take a third. I want you to find one using arcsine and find the other one using the symmetry and get going. I want answers not from the same student. I'm going to pick one of you to give me the answers. Get going, all of you. One using the arcsine, one using the symmetry in the graph. And I'll do it at the same time you guys are doing it because I'm making up those problems. Okay. How are we doing? Anybody likes to lead or shall I pick one? All right, I'll pick one of you. If the student is not present, I move on. Matthew, sure, are you with us? Okay. Aziz, are you with us? All right. Caitlin. You guys hear me? Okay, Jacob, are you with us?
Yes, I'm with.
Okay, get going. What did you find?
I I was trying to write down the original problem, but I can't see the original problem based on your screen.
Sine 2t.
Sine is 1/3 equals 2t, so it's sine.
So sine 2t
Over 1/3.
1/3, which gives us what?
I got 0.3398.
Okay, it means 2t
And then divide by 2.
sine inverse of 1/3.
Right.
And t is, you divide by 2.
So I got 0.1699.
1.699. Absolutely correct. Okay, that's one value.
Yeah.
And which one this is going to give us? So this is a third. And I draw that line. And this would give me one value. This is going to give me this one right there.
And then your other value is 2.9716.
Yeah, I usually want the work, because if you guys don't show me the work, I will not give you credit, because I want to know where you're getting those answers from. Is that very clear? Because if you show me the work and you do a mistake, I can give you partial credit.
Right.
Otherwise, partial credit will go out the window. If you do any mistake, so I need the work. So how can we get, so this is one value, so I'm going to get it, call it T1. How shall I get the other value using the symmetry?
You're taking your period minus your answer.
No. Let's go to the graph. This is the other value. How can I get this one?
Oh, I apologize. It's pi over 2 minus 1.6.
Yeah, it's pi over 2. It's not the period. You have to look at your graph. This is 0.169. It's the same thing as this piece. This here is 1.699. So the value I want is going to be pi over 2 minus 0.1699.
It's 1.4.
How much?
1.4.
1.24. And that's really how we're going to get those values. Just look at your graph. Do not memorize algorithm. Graph it and look at your graph.
I got 1.4.
Yes, it should be 1.4. I got also 1.4 myself.
Okay.
Yeah, 0.08. But I trusted you when you told me 1.20.
Yeah.
Okay. So that's really what we got. So you have to look at the graph. Just look at the symmetry within the. All right. So this is as far as last lecture. You make sure you go over those. You make sure you do them by yourself. There is no other way you're going to learn the material. I mean, no other way. All right, so now we look at the rest problems of the review. Now, of course, every page, everything on the review will be on your exam. Now, the second big part of the review is the idea of law of cosine, the law of sine, and as well as what happened in a right triangle. So in the right triangle, so I'm going to look at number 13, actually. So in the right triangle, we have the main property. So we write what's happening in a right triangle and then in a non-right triangle. So in a right triangle, so basically trigonometry in a right triangle. Okay. So if we have a right triangle like this, 90-degree angle, ABC, and then we have the famous Pythagorean theorem. Okay. Total memory, because I think it's being drilled in your head since I don't know which age. And then if this is theta, the sine of an angle is always the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. Then the tangent is always sine over cosine. Nothing changed in that. Sine over cosine, which is in a right triangle, will become the opposite over the adjacent. And then you have the cotangent, those you have to totally know them, is the adjacent over the opposite. And then you have the secant, which is 1 over cosine. So now it's hypotenuse over adjacent. If you want to memorize it, you do, but I don't think it's important. The secant is 1 over cosine. That's what matters for us. And the cosecant is 1 over sine. That's how I want you to memorize the secant and the cosecant. Even the tangent, I want you to know it's sine over cosine. And in the right triangle, it becomes the opposite over adjacent. Okay, so we're going to do 2 problems in the right triangle, and then we move to non-right triangle. So very simple. Suppose I have number 13. Usually you're good at those problems. It's number 14 that you messed up on your quiz, something along those lines. So in number 13, you have A is 4, C is 6, and there is no B. The question is find the sine of A. So the sine is going to be the A. So I will only do the sine and I will do the secant. So the sine of A is A4 over the hypotenuse, which is C. So it's equal to, sorry. Yeah, I'm right. So it's 4 over 6, which is the 2/3. Okay. Now let us find the secant. Okay. The secant is 1 over cosine. So to find the secant, I need the cosine. So I'm going to back up here and find the cosine. So the cosine is the opposite. So that's the A. Sorry, am I doing something wrong? No. This is A. It's going to be B divided by 6. But what is B in this problem? Can we find B very quickly? How can I find B? This is my Pythagorean theorem. We have A squared. Let's find B. We know that A squared plus B squared equals C squared, which give me the following. That B squared is C squared minus A squared. It means this is equal to C squared is 36 minus A squared, which is A is 4, this is 16, which is equal to 20. So it's gonna give me B equal the square root of 20. So now that I have a B, the square root of 20 over 6. That's my cosine. So my secant is gonna become 1 over that. So it means 1 times 6 over the square root of 20. And that's what gave me my secant. Easy questions. Of course, expect stuff along those lines. Now that I'll do number 14, because some of you had difficulties with that on the quiz somehow, something went wrong. So number 14, we have the following. We have an ant walks up a ramp at an incline of 12 degrees. So this is a ramp right here. And our slope, this is a ramp. And the ant is going up this ramp. At an elevation, at an incline, it means this angle here is 12 degrees. That's what it means. After 2 minutes, you know, remember this is an ant, it's very slow. After 2 minutes, its vertical distance from the ground is 12 inches. So the ant is moving along this ramp after 2 minutes. It's reached a point after 2 minutes. It's somewhere here. And at this point, the distance from here to here is 12 inches. That's what the vertical inches. Okay. So the ant starts here, it move. After 2 minutes, it's right there. And it's 12 inches, the vertical distance from here. the question is, how fast was the ant traveling in inches per minute? So it's moving. And the question is how fast? So I'm telling you that the speed is the distance it moved, how much it moved, divided by the time. That's what the speed. So to be able to find how fast it was moving, I want to know how much did it move. So the question is really boiling down. If I call this is d, so the question is I need to find, so the speed here is how long it moved. It started from here. It's right there, divided by 2. That's the speed. So to find how fast, I need to find the d. So now how can I find the d? That's a right triangle. I can use everything I know about right triangle. I need the d. I have it 12. So I can use the sign. The sign of 12 is going to be 12. And now I am in degree divided by d. Now I need to solve for d. So I multiply both by d. So I multiply by d because I need to solve for d. So I need to bring it up to the numerator. And this would give me d times the sign of 12 equal to 12. So d is 12 divided by the sign of 12. And this would give me how much it moved during those 2 minutes. And since my angle is in degree, I have to give my put my calculator in a degree mode. Okay, and then I will get d equal 12 divided by the sign of 12, which giving me 57.716 inches. Okay. So this means, so in 2 minutes, the ant traveled 57 inches. So the speed is, it took us 2 minutes to do that, divided by 2. And this would give me 28.858 inches per minute. Okay, and that's how fast it was moving. So it's just a matter of finding a distance traveled. And to find the distance, I just look at the picture and I have to use, that's a right triangle. I'm allowed to use everything about right triangles, that the sine is the opposite over the hypotenuse. I have the opposite, I'm go after the hypotenuse. Questions? Okay. So in a right triangle, this is the picture we have. Now, in a non-right triangle, okay, what we have is the law of sine and the law of cosine. The law of cosine, which is, you have all the version for you guys. One of them would be cosine A. And the same, if I put angle B, I'll have to put B here. Angle C, I put C here. So we have 3 other versions. And then we have the law of sine. Okay. We use the law of sine when we have an angle and the side opposite to it. If I know one angle and the side opposite to it, the law of sine will allow me to find other angle and other side. Okay. But if I don't have an angle and a side opposite to it, then the law of cosine will be actually the way to go, right? So please review that very, very well. So make sure you do the one I assigned on your quiz and make sure you do number 15 as well as 16 for your exam. So you remember how to handle those problems. You will be definite. Everything here you'll be tested on. The last thing I would like to review with you are the polar coordinates. And let us recall how the polar coordinates work. So basically the formula you guys need are what happened in a right triangle. You need what happened in a non-right triangle. And then finally, polar coordinate. Okay. So let us remember the idea of polar coordinate. The idea is that every point in the plane, any point in the plane, we can locate it using two systems of coordinate. Either the x and y, which are the Cartesian, or r theta, which are the polar. Okay, so in the picture, this is x, and this is the y, this is the theta, and this is the r. Okay. Now, the question is, if I know the x and y, how can I find the r and theta? And if I know r and theta, how we find x and y? So you should know the conversion between polar and Cartesian. Okay. So the first one is, the easiest one is from polar to Cartesian. It means if I know the r and theta, I know r and theta, then what's x and y? So here we know r theta. And then the x is just the cosine. The y is r sine. Okay, from polar to Cartesian. Okay, now from Cartesian to polar. Okay, so here we know xy. We know r theta. R is always Pythagorean theorem, square root of x squared plus y squared. Theta is problematic, as I said before. The only thing we know that the tangent is y over x. But theta, it depends on which quadrant my point is. So theta depends on the quadrant. It's the arctangent as long as my angle is in the first and the fourth quadrant, because that's the arctangent only give me the angle between minus pi over 2 pi over 2, and the arctangent plus pi if you are in quadrant 2 or quadrant 4. Pi if I am working in radian, 180 if I am working in degree. So it depends. If I ask the angle in degree, then you add 180. If I ask the angle in, so basically this piece and this piece should agree. So you cannot add radian to degrees. If this is degree, this should be 180. If this is radian, this should be pi. So we have to be very careful with the unit we're using. So that's really the relationship between conversion between polar and Cartesian. All right, so I will do 2 problems, I guess, and then I'll look at 21 and then wish you good luck. So here my question is, the first one is sketch the point with the given polar coordinate. So if this polar coordinate, sketch the point, it means this is the r and this is the theta, okay? If I have the circle, it means the angle is measured in degree. If I don't have a circle, this means radian. So we have to know what's really happening. So I have 4, that's radian. I don't have a circle, it means this is radian. And -3, that's in radian. And the first one is r. So for example, suppose I want to sketch the first one, this point. What does it mean? R is 5. It means that's how far the point is from the origin. The theta, so here r is 5. And the theta is 4 radian. Now 4 radian is, because we need to sketch it, is almost how many degrees, just intuitively. Anybody can kind of have a feeling. 4 radian is almost how many degrees? I gave you once the conversion. A radian is almost 57 degrees. So this will help us a little bit visualize. So 4 radian, it means it's going to be almost 240. So 4 radian is going to be somewhere in here. That's 4 radian. And from here to here, I have 5 units. This is the point of interest for us. Okay, so we have to be very careful with the unit. Right? Now, convert polar to Cartesian is very simple. I will not do that. We just apply the formula verbatim. Now, convert the Cartesian to polar. It means that those points are given. I pick one of them. I'm going to pick this one. Those are the Cartesian. So it means that 3 and minus 2. 1, 2, 3, and minus 2. This is my point. And I want the Cartesian. It means I want the r and I want the angle, theta. Okay. So we can do that quickly. R is always the square root of x squared plus y squared. It means 9 plus 4 square root of 30. Theta. Now, let us note that theta is in the 4th quadrant. Okay, we have to know where my angle is because it's helping me. And I'm going to use the fact that the tangent is y over x. Because I am in the 4th quadrant, the arc tangent is going to give me the angle. It's going to be negative, but it will give me the angle. It's going to be minus 2 over 3. If my angle happened to be quadrant 2 or quadrant 3, we have to add the pi to it. The last thing is I will look at 21 and then I still have 4 minutes. 21. And make sure you go over 20 by yourself. I have the solution on bright space. So 21, give inequalities in r and theta that describe this region. Okay, so I have this region here. I want to describe it. So we need inequality. All right, okay, we say like if you have a point in this region, what characterizes the r and the theta? The r, how far it is always between 2, no, 1, 2, between 3 and 4. So the r is between 3 and 4. What about the theta of this angle? If I take a point here, where is the theta? The angle vary from where to where? It goes from here all the way to here. So the angle vary between minus pi over 2 and pi over 2. Because theta represents the angle, so I ask myself, my angle go from where to where? It starts from minus pi over 2 to 0, all the way to pi over 2. And that's how we describe this region. Okay. Finally, this one. Let's describe this region. Right. Means if I take a point here in this region, what characterizes the r? If I take any point here, r cannot exceed 1. It can go from 0 all the way to 1. So r, how far it is less than 1. But the question is, what about the angle? If I have a point here, remember, theta is the angle. What characterizes the angle? It's between what and what? The theta, the angle is between this value and this value. That's where the angle is going to be. So the angle cannot be pi over 2. It's between this value and that value. Now, what's this value here? If you look at the graph, anybody can imagine and know what this theta is. This point is 1, -1, -1. So looking at the picture, it means this is going to be, this little one is a pi over 4. So I'm going to have from here to here, 1 to 5 pi over 4. And this one right here, so that's 5 pi over 4, all the way to here. This is going to be 7 pi over 4. That's the description, right? Okay. Any question from your part? All right. The exam doesn't have a lot in it. Make sure you go over every single review problem. And as I promised, if you guys do well, I will average, and you do better. If your exam 2 is better than your exam 1, I'm going to average exam 1 and exam 2, and the average will replace your exam 1. So it's your chance to actually improve your grade on exam 1. And I have office hours tomorrow in the afternoon, so from 2:30 to 3:30. Usually I have students from other classes, but this class, the students are not showing up. So I encourage you to come and ask questions if you have. Any other questions?
Yeah, I had a question about the last one you just did.
Yes, go ahead.
How did you, I was going to say use Pythagorean theorem to figure out what the, oh no, that would just give you the r as radius. How did you figure out the angle?
Okay, I want to figure out this one, right?
Right.
This point is -1, -1.
Mm-hmm.
Okay, so what this angle could be?
45.
45. It means pi over 4, right?
Right.
So from here to here, how much do I have?
You have.
If you want, pi.
Oh,
plus,
I see. 5 pi over 4. Yep. Okay.
Which gonna give me 5 pi over.
I was just not thinking about it. It's pi plus 1 over 4 pi.
Yeah, exactly. And this one is, you can think about as 2 pi minus pi over 4,
Right.
which is 7 pi over 4.
I don't know why I just had a blonde moment for a second.
That's all right. No problems with that. Don't have them on Wednesday though.
Right.
Okay. Anybody has any other questions? Okay, the class is dismissed. Every student who have any questions